बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि व आलिहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा अस्सलातु वस्सलामु अलैका या सय्यदी या रहमतल लिल आलमीन आमीन बिजाहि खातमिन नबिय्यीन अल्हम्दुलिल्लाहि रब्बिल आलमीन। In this video, I will be covering the key concepts with some important questions from the complete S1 syllabus in a structured and concise manner. The aim is to help you revise effectively by refreshing, summarizing, and organizing the most important topics. I highly recommend that you watch the lecture until the end to gain maximum benefit. This session is designed to support your final revision and strengthen your understanding of the subject. Wishing you all the very best for your exams. Be humble. Let's begin. We will begin with binomial and geometric distributions. Binomial distribution, we must know the conditions. There are only two outcomes in n number of fixed trials. Trials are independent and probability of success is constant. These are four conditions. Only two outcomes in n number of fixed trials. Trials are independent and probability of success is constant. You must remember these conditions. Write in capital form x is discrete and read this as x is binomial with parameter n and p. N means number of fixed trials and p means probability of success, which is constant. This is the binomial distribution formula. It's NCX p power x q n minus x, where x can take values from 0 to n and n can take these values 1, 2, 3 till 30, usually till 30 for binomial, and more than 30 we normally use normal approximation. To make calculation simple, we use these results. X0 meaning nones, means none. So its formula is q power n. X is equal to n, n means all, the power formula is p power n. At least 1, write in this way, 1 minus p0, which is 1 minus q power n. More than 3 if n is 12, and if we need this probability more than 3, write the direct method. First list the numbers by using direct method. 4 to 12. Now since this method is lengthy, so use 1 minus those numbers which are not in this list. This is indirect method, this is direct method. When direct method is lengthy, then use the indirect method. Indirect method means 1 minus probability those numbers which are not in this list. The formula of mean is NP and variance is NPQ. Normal approximation to binomial distribution. Condition. There is just one condition. Both NP and NQ are greater than 5. Write in this way. Both NP greater than 5 and NQ greater than 5. Hint. Both methods of finding the probability are lengthy. If both methods are lengthy, then we use normal approximation. And we do continuity correction as well, which is the correction of plus minus 0.5. And for that, we use number line. See, if we have to find this probability x greater than 40, then list the numbers first. Write the first inclusive integer on the number line. Since this is greater than 40, so write 41 here. Write this number here. And the rule of number line is, if we go on right side, we take the lower bound. So the lower bound of 41 is 40.5. So after continuity correction, this number would become 40.5. You would find this probability z greater than 40.5 minus np over under root npq. I would explain this later. So the rule is, if you go on right side, take the lower bound. If you go on left side, take the upper bound, but make sure you must mention the first inclusive integer here. Don't mention 40 here. 40 is exclusive. So two rules. First inclusive integer should be mentioned here, and according to this sign we are going on right side, take the lower bound. So we would find this probability, alright. Now x less than equal to 50. Let me explain this in the context of z. 40.5 np divided by under root npq. This is the way we convert the statement from x to z. We use mean of binomial and variance of binomial here. Now x less than equal to 50. So first inclusive integer is 50. We are going on left side, take the upper bound, which is 50.5. Alright. Solve with this. Probability z less than 50.5 minus np under root npq. Change the mean and variance. Mean by np and variance by npq. This way. This is the way we convert a statement from x to z. Now geometric distribution. The conditions. There are 4 conditions. The repeated trials are independent, meaning trials are independent. The repeated trials can be infinite in number. There is no fixed number of trials here, like in binomial. There are just 2 possible outcomes for each trial, success or failure. This is similar to binomial. These 2 properties are exactly similar as binomial. These 3 in fact, 1, 3 and 4. In binomial the trials are independent. In binomial there are only 2 outcomes and the probability of success is constant. So these properties are exactly similar as of binomial, but this is the difference. In binomial the trials are fixed, whereas in geometric the trials can be infinite in number. And that is why this distribution is also known as an infinite distribution. This is the way to write geometric distribution. X is geometric with parameter p, probability of success. And this is the formula of geometric distribution. Q power n r minus 1 times p. X is r and r can take these values 1 to infinite. We repeat the process until we get our requirement in geometric distribution. This is Q1 minus P. Rules to make calculations simple and fast. Without using these rules, you won't be able to solve questions of geometric distribution in less time. So x greater than r, this is Q power r. X greater or equal to r, same, just minus 1 here. Now x less than equal to r, this is 1 minus qr, and is exclusive is just minus 1 here. So learn these rules by heart. Mean of geometric is 1 upon p, variance is q upon p square, and mode is 1. Okay, 1 minute break and then I will continue this 20 minute rule. Well, if you find this video helpful, please share it with your friends so they can benefit as well. All the very best for your S1 exam. Okay, let's continue. In Greentown, 70% of the adults own a car. So this is P. A random sample of 8, this is N, from Greentown is chosen. Find the probability that the number of adults in this sample who own a car is less than 6. So we need this probability, and we have binomial distribution with N 8 and P 0.7, whereas Q is 0.3 because Q is 1 minus P. And this is the formula of binomial distribution. So we need these numbers 5, 2, 0. So this method is lengthy, direct method. We have a lot of numbers here, so use the indirect method. So indirect method is 1 minus those numbers which are not in this list. So 6, 7 or 8. Now get the probability with the help of this formula. NCX, PX, QN minus X. And must write your answer up to 3SF. Next point, a random sample of 120 adults from Greentown is now chosen. Since N is large, use an approximation, normal approximation. In binomial, whenever it says use an approximation, always use normal approximation. In S1, okay, not in S2. In S2 there is one other approximation. I'm not discussing that here. Use an approximation to find the probability that more than 75 of them own a car. So first write direct method because I need the first inclusive integer here. See, x greater than 5, direct method. This method is lengthy. This is also lengthy. That is why we are using normal approximation here. We can't solve this question through binomial distribution, neither by using direct nor by indirect method. Now get NP. NP is 84. Q square, which is NPQ 25.2 NPQ. Now this is the conversion from binomial to normal, mean variance. Now draw the number line. Make sure you write the first inclusive integer here. The first inclusive integer is 76. Must mention that integer here. Since we are going on right side, therefore take its lower bound, which is 75.5. Now convert this statement from x to z with the help of this formula. X minus NP divided by NPQ under root. This is NP, this is NPQ under root. From here, this is a routine normal distribution question. I will discuss normal distribution later in this lecture. So copy Z here. And this value must be up to 3 dp because in table you can find maximum 3 dp value. Okay, this is according to sketch a large area, therefore it's phi, and this is the value of phi. I will explain this how to find from this normal distribution table in normal distribution chapter, okay? So this is the way to use normal approximation. I explain this logically by using both methods, direct method, indirect method. Both methods are lengthy. Therefore, we are using normal approximation, and that is why normal approximation is used here. And for normal approximation, we must have NP, NPQ, continuity correction. The first inclusive integer should be here. We are going on right side, take the lower bound. Must mention NPQ here under root. It is compulsory to mention NPQ inside the root, with root. Now write this value up to 3 dp. Shade the area, make a rough sketch. This is large area, that is phi. And this I will discuss later in normal distribution chapter, how to find phi from normal distribution table. Alright, I'm just discussing the important thing. Find the probability that for a random sample of 12 days, Moina messages Pasha on no more than 9 days. Now what does it mean? No more than 9 days. This means greater not equal 9. No more than 9 days means this thing. And the opposite of this is less than equal to 9. This is here. We need this probability, and this means less than equal to 9. You just need to find this probability. This is the normal approximation. I am leaving this. Binomial and geometric distribution. Okay, a fair six-sided die with faces these is thrown repeatedly until a 4 is obtained. You know, until means repeat the process unless you get your requirement, or until you get your requirement. So this is geometric. 4, fair die. So the probability of all number is 1 upon 6 each. So it should be 1 upon 6 here. P is 1 upon 6. Find the probability that obtaining a 4 requires fewer than 6 rows. Less than 6. I told you the rules. It's 1 minus q power, r minus 1. So this is according to that rule. 6 minus 1, 5. You can write this in this way. 6 minus 1. That's the rule. 1 minus q power r minus 1. This is r. So this will become 5, and must write your answer up to 3SF. Now from here this question is binomial. Has become binomial. Why? Because of n, fixed number of trials. Here trials were infinite. Repeat the process until you get your requirement. Here the trials are fixed, 10 trials. Find the probability that a 4 is obtained at least 3 times out of 10. So at least 3 is 3 to 10. Direct method, which is lengthy, use indirect method. Numbers which are not in this list. Alright, another question of geometric. An ordinary fair die is thrown until a 6 is obtained. So, again binomial, geometric. So, 1 upon 6 is the probability of P of 6 in a fair die, on a fair die, more than 8 throws. So, more than 8, the formula is q power. Px greater than r is q power r. This is here 8. Let me show you those rules again. We are on page 23. These rules are here. See, these rules are extremely important while solving the questions of geometric distribution. We must know these rules. These rules makes the calculation very simple. So greater than r, q r. We did this one in last question. So r minus 1. Page 23. This is here. Alright. 2 ordinary fair dice are thrown together until a pair of 6 is obtained. This. The number of throws taken is denoted by random variable x. Alright. So until a pair of 6, that means geometric. Mean. The mean of geometric is 1 upon p. So just write reciprocal of p here. 1 upon p means this is p. So 1 upon p is the reciprocal of this, 36. Find the probability that obtaining a pair of 6 takes either 10 or 11 throws. No problem. 10 throws. So that means q power 9 times p. This is q power 10 times p on 11 throws. Here is the formula of geometric distribution. Normal approximation to binomial distribution, we have done this. Here is the justification of using normal approximation to binomial. You have to show comparison. NP is 90 greater than 5. NQ is 60 greater than 5. This is the way to justify the use of normal approximation. Must write in this way. Don't write in this way. NP greater than 5, NQ greater than 5. You have to show the comparison. This is the right way. This is the way to justify the normal approximation to binomial distribution. Let me find a good question of geometric distribution and combined question of geometric and binomial. Okay, let's check this question. An ordinary fair die is thrown repeatedly until a 5 is obtained. So the probability of 5 is 1/6 on a fair die. Write down the mean. Just write the reciprocal of this. Mean is the reciprocal of P. Find the probability that a 5 is first obtained after third throw but before the 8th throw. Very simple. X is between 3 and 8. After the third and before the 8th. So these are the required number 4, 5, 6, 7. For 4, write q cube times p, 5 q power 4 times p, and similarly for 7 q6 power p. And must write your answer up to 3SF. Find the probability that a 5 is first obtained in fewer than 10 throws. This is here. Fewer than 10 throws. 1 minus q power 9. Now this is two binomial models, a very important concept. In a certain country, the probability of more than 10 centimeter of rain on any particular day is 0.18, independently of the weather or on any other day. Find the probability that in any randomly chosen 7-day period, more than 2 days have more than 10 centimeter of rain. So this is the question. More than 2 days, more than 2 days have more than 10 centimeter of rain. So more than 10 centimeter of rain, probability is 0.18. So for this part, P is 0.18. And we need more than 2. This is the direct method. And this is the indirect method. So direct method, we have a lot of numbers. So use indirect methods. And indirect method, we write 1 minus those numbers which are not in this list. So 2, 1 or 0. Now this part is extremely important. You must be good at with these types of questions. Just 1 minute, please. Alright, for 3 randomly chosen 7-day period. Now this is extremely important. This is just 1 7-day period. 1 7-day period. And these are 3 7-day periods. 7-day 1, 2, 3. So 3 7-day periods. Find the probability that exactly 2 of these periods have at least 1 day with more than 10 centimeter of rain. Let me explain this in detail. So 2 of 3, that means write 2 here, 2 out of 3, so 3C2, P power 2 and Q power 1, right? For this part, we will use binomial 3C2, P power 2, Q power 1. But the problem is we don't have P. Now how to find P? For P, we have to use this information. Have at least 1 day with more than 10 centimeter of rain. Now this information will give you P for this part, and that is why this is known as two binomial models, because we need P, we find P with the help of previous model or previous part. See, at least one day we write like this, at least one, which is 1 minus q power n. See, at least one day, q1 minus qn, with more than 10 centimeter of rain. Now check this, more than 10 centimeter rain, 0.18. So P is 0.18, therefore Q is 0.82. Now substitute Q 0.82 here and N is 7. Okay, because for this part N is 7, P is this, Q is 0.82. So work for this and get P. This P is used over here. This is the way to find P for this model with the help of previous model, and that is why this is known as two binomial models. Please check this question very carefully. I'm waiting. All right, next question. In a certain country, okay, this is the similar question, just leave that. This is a normal approximation. Let me check this one. Okay, done. Let me check one important question of geometric and binomial. Okay, I explained that question from Feb March 2026 paper. Here is it. It is. This is Feb March 2026. Now this question, this second part. Anyway, let me explain the whole question. Suri has a bag containing 4 blue discs and 3 yellow discs. She selects one disc from the bag at random, notes its color and returns it to the bag. This means with replacement, so probability is constant. That is why this can become a binomial and geometric, either binomial or geometric. So she repeats this process until, this is geometric, she obtains a yellow disc. Find the probability that Suri obtains a yellow disc for the first time on her 4th selection. X4, this is very simple, Q cube times P. Probability of yellow is 3 upon 7. Give your answer up to 3SF. This part is very simple and of just 1 mark. Now this is an important part. Find the probability that Suri obtains a yellow disc for the second time on her 5th selection. So there is a restriction on the second disc and no restriction on the first disc. First disc is random. The selection of first disc is random. So that is binomial. In binomial we use C, that means random. So check this here. The selection of the first disc is random, so anyone from 4 can be the first disc, and this 5th one is fixed. This should be the second yellow disc. So since we can have yellow disk here or here or here or here, anywhere out of 4 positions. So we are using binomial here. 4c1 3 upon 7 4c1 p power 1 q power 3. This is here, and this is for the second disk, which is the 5th disk, and give your answer up to 3SF. Please check this solution, and you must be good at with these types of questions, and you can find these types of question in 2024 2023 worksheets. Because of lack of time, I'm not discussing those questions. I'm just discussing one question of each type. So we have done this. So binomial and geometric, we have completed both. Now the next chapter is normal distribution. For normal distribution, let me explain some important concepts first, and then I will go for these questions. This is normal distribution table. I will let you know how to find phi and phi inverse from this. Please 1 minute break, take a 1 minute break, then I will start normal distribution. Okay, let's continue. Normal distribution curve. This is the way we write normal distribution, and one second please. All right. So the curve is symmetrical about mean mu, and the total area is 1, and this area is 0.5, and this area is also 0.5. This is known as normal distribution variable, continuous variable, or normal variable, continuous random variable. Area under the graph corresponds to probability. Standard normal curve, Z is normal with mean 0 and variance sigma square is 1. Approximately 99.9% area lies between 3 standard deviation of the mean. I will explain these terms later in this lecture. So this area is approximately 99%. 99.9%, minus 3 to 3, which is approximately 100%. Exactly 99.9% and approximately 100%. Okay, this is exactly 99.9% lies within 3 standard deviation of the mean. Within 3 standard deviation of the mean means mu plus minus 3 sigma. Mu is 0, sigma is 1, so plus minus 3. Conversion, this is the formula of conversion from x to z. X minus mu over sigma. So if mu is 40 and this is sigma square is 50, so write 40 here and under root 50 here. In normal distribution, continuous distribution, these signs mean same thing. Direct normal, phi. If area is large, see, with respect to this area, from this reference line, this area is larger area. So this should be phi. And how do we know we need this area? Because of this sign of inequality. We need values which is less than A. Area left side of A, less than A. So larger area is phi and this small area is 1 minus phi. And this number should be here. This is the smaller area, so this should be 1 minus phi A. Large area 1 minus phi, this letter is here. .125. So we need this area, right? So this should be phi, large area. This area is 1 minus phi. This area, large area, so phi. Since we have numerical number, like numerical value, known value, so we don't take negative sign here. If this is unknown, what if minus A, then we had to write phi minus A. Remember this, if known, ignore negative, don't write negative. If unknown, must write negative. This area is phi. Why this is phi? Because of symmetry. Both areas are same. That is why we write phi positive number. You just need to remember this. If we have large area, just write phi. Small area, 1 minus phi. This is 1 minus phi. This number. Between, so between means this number is here, this number is here, and we need this total area. We need this area between. Okay. So for this area, first get this area, this total, then get this area, and then subtract this from this. Get this, let's suppose this area is A, get this, let's suppose this area is B, then you should write A minus B for this area. So phi this minus phi this. So here phi of this 1 minus phi of this, why? This total area is phi, whereas this area is 1 minus phi and we need this area. So this minus this will give you this area. Phi 1 minus phi. Okay. Label this here, this here. So this area is 1 minus phi and this area is also 1 minus phi. So subtract this and this. Or directly you can write phi of this minus phi of this. This is here. 1 minus phi, 1 minus phi, so directly phi of this, if both are negative. How to remove modulus? If we have modulus z less than a, right, minus z lies between minus a, and we need this area. If z is greater than modulus is greater than a, then write in this way. These two areas are required. This is for standby. So what if we have this, then write in this way, z lies between this number and this number. So phi of this, 1 minus phi of this minus this result. If we have greater sign, then write in this way, z less than this, negative, and z greater than this, positive. Now just get this area, 1 minus phi, and double it, because both are same. Okay, this question. In a certain town, the time x hours for which people watch television in a week has normal distribution with mean this, standard deviation this. Alright, find the probability that a randomly chosen person from this town watches television for less than 21 hours in a week. So less than 21 we needed. So 21 minus mu, here is the formula of z. So mu is here, which is 15.8, and standard deviation is here. Now get this value up to 3 decimal places. Now how to find, and this area is required, large area phi. Now how to find this from normal distribution table? Let's check this. MF19. We have to find phi 1.238. See, 1.238. 1.2, check under 3, 1.23, and check the number under 8, which is 15. And make sure you, whatever the number you take from this column, multiply it with 0.001. So this will become 0.0015, okay? Now add, because of add, so 0.8907 plus 0.0015. This will give you the phi. This is the way to find phi from the table. So 0.594. Let me check this again. What was the number? It was 1.238. 1.238. I think that number is wrong, which I wrote. Let me check the correct answer. 0.8907 plus 0.0015. It's 0.8922. 0.8922. Let me correct this. 3SF. Alright. Now inverse normal. Here is inverse normal. Inverse normal means area will be given and corresponding z value would be required. Like this. See, area is given 0.9 and we need this value. This is known as inverse normal. Direct normal, this value is given and area is required. This is inverse normal, therefore we shade in the opposite direction. In direct normal, we shade in the same direction. See, this is the direct normal question. We need probability, so we shade it in this way. Inequality is less than, we shade it in the same direction. See, from this reference line, we shade it in this way. But in inverse normal, we shade in the opposite direction of the sign of inequality. We shade in this way. We shade this area in the opposite direction of the sign of inequality. So this inequality is less than, so we shade in this way, lower to upper tail, like this. Got it? Since this area is greater than 0.5, so we cross the central line. Till central line area is 0.5, so 0.9 maybe is here. Alright, so this is large area, so it should be phi A is equal to 0.9. Then phi inverse. And now how to find phi inverse? I explained this after completing inverse normal. So shade the given area in the opposite direction of the given sign of inequality. For this, shade in this way, and for this, shade in this way. That's the rule. And why do we shade? To check the position of this, whether this is on right side of 0 or left side of 0. Now this area, shade in this direction. Cross the central line, because this area is greater than 0.5. So this A is here. So phi of A is equal to 0.75. Right? So A is phi inverse 0.75. Now let me tell you how to find phi inverse 0.75. We find phi inverse here in this section. So either look for 0.75 or a value which is close to this but less than 0.75. Okay? Now try to find 0.75. See these two numbers. This number is less than 0.75 and it's close to 0.75. We look for a number which is less than and close to required number. Either find 0.75 which is not available in this table. So find a number which is less than 0.75 but close to 0.75. So this is the number. This number is less than and close to 0.75. Now read this number in this way. First digit 0.6, this number is under 7, so 0.67, and how much is missing? What should be added into this number to get 0.75? 1 4 is added, so is required. So check 1 4 in this row. 1 4 is not available, a less than number is available, 13. So take 13. So the answer is 0.674, right? So 0.75, phi inverse 0.75 is 0.674. This is here. Now for this, how to shade this area? Shade in this direction, lower to upper tail, but this time area is less than 0.5. So stop shading before 0 and label this A here. And remember, since this is on left side of 0, this must be negative. And I told you earlier in this lecture that if this is unknown, then we take sign. We take this number with its sign. Since this area is small, so it must be 1 minus phi minus A. So 1 minus phi minus A is equal to 0.3, this area. So phi minus A is 0.7. So minus A phi inverse 0.7. This is from table 0.524 and shift minus here. Minus 0.524. Okay. I am showing one more step for your conceptual clarity. Alright, Z greater than A, so shade in this direction because this is inverse normal. So start from upper tail to lower tail, this area is 0.9, large area. So again this number is on left side of 0, so this is negative. So write 5 minus a 0.9. Then it would become 5 minus a 0.9 minus a 5 inverse 0.9. A is 1.282 negative. One extra step. Now this time area is on right side of 0 and this A is positive. So a small area 1 minus 5A and get this answer. You must be good at inverse normal. Now questions. This is the inverse normal question. X is less than k, we need the value of this and probability is given. So convert this statement into Z first. K minus mean, it's given. Mean is 15.8, standard deviation 4.2. Now shade this area in this direction because of the sign of inequality. So this area 0.75 and this unknown is on right side of 0, so it's positive. Since area is large, so phi of this 0.75, this is here, phi of this is 0.75. This is phi inverse, get its value from table 0.674. I use a calculator, that is why I got 5, but if you write 0.674 it's perfectly fine, and that's the value of k. This is one of the most important question and the most repeated question. You must be good at with this question, simultaneous equations. The lengths of leaves of a particular type of tree are modeled by a normal distribution, sample of 500, and finds that 42 are less than 4 centimeters. See, less than 4 centimeter are 42 out of 500. So this is the way to make the expression. Now 100 are more than 10 centimeter. More than 10 centimeter are 100. So make these two equations yourself with the help of given information. Now convert these statements into Z with the help of x minus mu over sigma formula. Now shade this area. See, this area is less than 0.5, so this area is here. And this unknown is on left side of 0 and it must be negative because left side of 0. So write this small area, so write this as 1 minus phi, this thing with negative sign is equal to this. Now bring this here and shift on right side. So this will be positive and this is negative. 1 minus this will give you this. Now take phi inverse and get an equation of mu and sigma. Now for this, since we have greater sign, so shade in this direction. Area is very small, stop shading well before 0. And this unknown is positive because this is on right side of 0. Since area is small, so write 1 minus phi, this is equal to 0.2. Now get phi inverse of this and get the another equation. From here we got this equation, from here we got this equation. Use elimination or substitution, it's optional. I usually use elimination and get the values of mu and sigma. Please check the solution again. This is one of the most important questions. You should practice as many S1 past papers as possible to be good at S1, to manage your exam time, to get the flow. At least 20 to 25 papers you must have solved. Your exam is on this Tuesday on 12th May. So today is 7th May. Sorry, 8th May I guess. Today is 9th, oh my god, 9th May. So you have only 2 or 3 days. Try to solve as many papers as possible. Expect means n times probability, and between mu minus 2 sigma and mu plus 2 sigma. This is here. Now convert this statement into z. Mu cancel, sigma cancel, so we have this number, and we have done this rule earlier in this lecture. This is phi 2 and this is 1 minus phi 2. That's the answer of the probability. Now multiply this with n, which is 800. See, how many leaves? So 0.6 can't be a full leaf. So always round these types of number to backward, in backward direction, okay? 763. Some important terms. A very important question. Find the probability that the time taken to complete the task by a randomly chosen employee differs from the mean by less than 15.0 minutes. So differs from the mean, that means mu plus minus 15.0. Now write this information here. See, mu is here, mu plus 15 is here, mu minus 15 is here. Less than means this area. What if it says more than? Then either this area or this area. Please remember this. Less than means this area and more than means this and this. So we need this probability. So mu minus 15 point, just write this, x lies between this and this. So convert this statement into z. Mu cancel, mu. So minus 15.0, sigma was given 9.6 in this question. Here it's given 9.6. This is phi and this is 1 minus phi. Now this statement means this thing. Make a rough sketch, understand the statement, shade the right area, and then write the a probability equation. Another question of this type here. Find the probability that the weight of a randomly chosen apple of this variety differs from the mean by less than 4 grams. So write mu, this is mu plus minus 4. And this area, less than means this area. So mu plus 4, mu minus 4. We have mu, it's 82, this is 86, and this is 78. 82 minus 4 is 78. So we need this area. You can easily calculate this. Convert this into z. This is phi, this is 1 minus phi. Another question. How many rods in the sample would you expect? Expect means n times probability. Have a length that is within 0.5 centimeter of the mean. So mu plus minus 0.5, within means between this area, this. So mu plus 0.5, mu minus 0.5, right? So get this thing, this. You can also use this form here, mu plus 0.5, mu minus 0.5. Whatever is easy, you can use that. By the way, this thing is better, mu plus 0.5, because mu will be cancelled. But both are fine. So after converting this into z, we have this. So this is 5, this is 1 minus 5. And expect means 500 times this. Since this means rods, so 0.4 can't make a full rod, so 394 rods. Normal to binomial. Hint, in normal distribution, if you get n less than 30, then find p from the normal distribution and use binomial distribution. See, the first part is of normal. In fact, the whole question is of normal. 365 days, we have mean variance. The question is how many days of the year the daily sales can be expected to exceed 3900. So convert this into z. This is large area, so just 5. Now multiply this number with 365, 316 days. Now this part is important. This is not important. This is in fact inverse normal. Just do this. I think this part is normal to binomial. Okay. So this is inverse normal. So shade this area. This area is small, so stop well before 0. So this unknown is here and it's positive. Since the area is small, so it should be 1 minus 5. So 1 minus 5 is 0.122. So get m up to 3SF. Now this is very important, normal to binomial. Find the probability that the daily sales at this petrol station exceeds 8,000 liters on fewer than 2 of 6 randomly chosen days. I told you n would be given less than 30 and you have to find p of binomial with the help of normal distribution. So it says exceeds 8,000, exceeds 8,000. Less than 2 out of 6 exceeds 8,000. So this information will give you p. Now check this here. Exceeds 8,000. This is here. 0.122. So this is p of binomial. Less than 2 means only 2 values, 0 or 1. Use binomial and get the answer up to 3SF. You must be good at with these types of questions. Alright. We have done normal approximation to binomial. I'm just leaving this. So we have done, alhamdulillah, binomial, geometric and normal. Alhamdulillah. Now the next chapter is probability. And then we will do probability distribution. Where is probability? It's here. Okay, wait a minute, please. 1 minute break. Try to take a break. Try to take break while using iPads or phone. It's better for your eyes and our eyes. Well, if you find this video helpful, please share it with your friends so they can benefit as well. And please subscribe the channel as well. Inform your friends about this channel so that most of these students or more students can benefit from it. It's a charity. Every kindness is charity. Alright, so probability summary. For independent events, A intersection B is probability A times probability B. Mutually exclusive events, intersection must be 0 and union must be sum of these two. But to check whether the events are exclusive or not, we check this condition. If this condition is verified, then events are exclusive, otherwise not. And this is the condition for independent, just one condition. Conditional probability, we write find here, given here, probability of given here, and probability of these, the intersection of these two is here. F intersection G, common. Total probability is always 1, probability A, probability not A is 1, probability lies between 0 and 1 inclusive. These are the rules for probability. Alright, bag A contains 4 balls numbered 2, 4, 5, 8. These are here. Bag B contains 5 balls numbered these. Bag C contains 7 balls with these numbered. 1 ball is selected at random from each bag. Event X is exactly 2 of the selected balls have the same number. So check the same number balls. Common balls 8, 8, 8 and the question is 2 balls. Oh, alright, 2. So 8, 8, 2, 2. So the common balls should be 2, 2 and 8, 8. So 2 from box A, 2 is not here, so 2 complement from box B and 2 is from box C. So exactly 2 same number balls. So 8 is common in all, so you have to make possibilities from all. So 8 from A, 8 from B, 8 complement from C. Similarly 8 from A, 8 complement from B and 8 from C and so on. Now do the probabilities very carefully. So 2, the probability of 2 from A is 1 upon 4. 2 complement, all are 2 complement, so 1. 5 upon 5, this is 5 upon 5, so I wrote 1 here, or you can write 5 upon 5 as well. Next, 2 from C, 1 upon 7. 8 from A, 1 upon 4, 8 from B, 2 upon 5, and 8 complement 3 upon 7, and so on. It's better to leave your answer in fraction form. Now event Y is the ball selected from bag A has number 4, 1 upon 4. Done? Next, find X intersection Y. X intersection Y means from X we have same number balls, right? 2 balls have same number and Y means 4, number 4. So X intersection Y means 4 and 2 same balls. So we can have 4 from A, 8 and 8 from B and C. Both conditions. This means number 4 and this means 2 same numbers. 2 balls of same numbers. Okay. So see, from box A 4 and 2 same numbers, and event Y box A 4. So this is X intersection Y. Now we have to find whether events are independent or not. Now just substitute, use this equation. Always mention this equation. This answer is here. We have answers of these two. Not equal, so not independent. Find the probability that the 2 balls are number 2, right? Are number 2, given that exactly 2 of the selected balls have the same number. So 2 balls are number 2. See, 2, 2, this is 2 complement and same number. Same numbers means this. Two balls have the same number and two balls are number 2. So this entire thing is in denominator and this thing is in numerator. Two balls are number 2. For this type of question, use this solution, this one. Two balls have number 2, this is the requirement, and two balls have the common numbers, same numbers. This total should be in denominator. Same numbers in denominator and common is here. Okay, box A contains 7 red balls and 1 blue ball. Box B contains 9 red balls and 5 blue balls. A ball is chosen at random from box A and placed in box B. Okay, it could be either red or blue. A ball is then chosen from box B. The tree diagram shows the possibilities. Alright, complete the tree diagram. Alright, no problem. So 7 upon 8 is here, red ball, 1 upon 8 is here for blue ball. Now if the red ball is transferred, then there are 10 red balls, 10 upon 15. And this total is 1, so 5 upon 15, okay? 1 minus this will give you this result. Okay, if a blue ball is transferred into bag B, then this will become 6. So 6 upon 15 here, and this total is 1. So 1 minus this will give you 9 upon 15. Now the question is, find the probability that the two balls chosen are not the same color. Not same color means either red blue, either blue red. So 7, 8, 5, 15 and this is here. Okay. Find the probability that the ball chosen from box A is blue, box A blue, given that the ball chosen from box B is also blue. So this is in denominator and their intersection is in numerator. So blue ball, take this from here. Blue ball, blue ball. This is the denominator. And this is the numerator. Blue from A, blue from B. This is numerator and the sum of these two is denominator. See, this result and this result is in denominator. 7, 8, 5, 15. 1, 8, 6, 15 and the requirement is this. This is the requirement. This should be in numerator. Okay, table types questions. A total of 500 students were asked which one of 4 colleges they attended and whether they preferred soccer or hockey. The numbers of students in each category are shown. Okay, these are total altogether 500. Find the probability that a randomly chosen student is at C college and prefers hockey. C and hockey, 56 upon 500. For these types of questions, you must have totals, these totals. Although examiner have given you, but if not, then do the totals, horizontal and vertical, row totals and column totals. Now the next part. Find the probability that the randomly chosen student is at D college given that he prefers soccer. So this is the formula of conditional probability. D intersection S divided by S. He prefers soccer. So get the total of soccer. It's 280. This is here. And the common of D and S. D and S common is 120. So this 120 is here and the total of soccer is here. This is conditional probability. For independent events, one of the students is chosen at random. Determine whether the event's student prefers hockey and the student is at A college or B college are independent, justifying your answer. Okay, hockey and A or B. So hockey, A or B. So hockey, A or B. Check the total. Hockey A 86, right? Hockey A or B. So just get this total. hockey A, hockey B. So 32 plus 72 makes 104 divided by total, and altogether hockey 220, and A or B, just get the total of A or B, these two. So the common of H and A or B, H and A, H or and B. So just get the total of these two to get 104. Alright, this is enough for probability. Now probability distribution. Probability distribution is here. Okay, 1 minute break. Allahu Akbar. All right. Expectation and variance formulas. Ex, sigma x, px, although these formulas are given in MF19. Vx, ex square minus ex square. This minus the square of this. You must be good at, you must be used to with MF19. Always keep MF19 with you on your table while practicing S1 and P1. Construct the probability distribution. Okay, how to construct probability distribution? We need the knowledge of NCR. We must know how to use NCR. And NCR is used for random and without replacement events only. In probability, if events are random and without replacement, then you can use NCR. For with replacement, you can't use it. So, for this chapter, we must know how to use NCR, tree diagram, possibility space like this. If you toss two coins, head, head, tail, 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 head, head, tail, these outcomes. This is sample space, possibility. This is sample space. Where is sample space? Possibility space is a different thing. It is like this. That was the sample space, which I told you. Head, 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 sample space. So you must be good at possibility space, tree diagram, factorial method. Factorial method is used for with and without replacement events, for the order of the arrangements. So these things are important. Now, how to choose the value of x in the question? In every question they define x. So minimum, maximum. Okay. Given there are, let me check what is this. PH. Not sure what is this. PH, PB. Okay, let me change this. Let's suppose, I forgot what does it mean. Okay, let's suppose we have A here and B here. Like, or we can just suppose male and female. Right? So there are 6 male and 2 female. Now x is number of males. X represents number of males. And we have to select 4 people. The question is draw the probability distribution for 4 people, and there are, you have to select 4 out of 6 and 2. Find the number of selections of 4 people from 8, and X represents number of males. So males, minimum we can have, maximum how many males can we have? So we can have, let me make another diagram for this. X, male, male, okay. So maximum we can have 4 males, and minimum we can have here females. If we try to take 0 male, no male, then we must have 4 females, but here we have just 2 females. This total is 2, this is 6, 6, 2. So this is not possible, 0 and 4. So try to keep 1 male with 3 female, not possible. So at least we have, or minimum we will have 2 men and 2 females. So X, the minimum value of X is 2 and the maximum value of X is 4. So make the table for these values 2, 3, 4. This is the way we choose the values of X. Let me erase everything of these. I will explain this in question as well, no problem. Actually I forgot what does it mean, PB and HB. Alright. Okay, this is related to with this one. Oh, I'm so sorry. Paper bag, hard bag. Alright, I got it. Paper bag, hard bag. No problem. Okay, a book. Now I will explain this to you. A book club sends 6 paper bag and 2 hard bag, okay, to Mrs. Hunt, and she chooses 4 of these books at random. X represents the number of paper bag. Alright, paper bag, PB. So X represents PB. This is X. Now, how to choose the values of X? So paper bag, hard bag. Okay? So PH. Now write the numbers here. Try to take 4P, which is possible because this is 6. So we can have all 4P and no hard bag. Now try to take 0 paper bag and 4 hard bag. Not possible because this is 2. Even 1 and 3 is not possible. So 2, 2 is the only option for minimum. So minimum there are 2 paper bag and maximum 4 paper bag. So these values of X can take these values. This is the way to select the values of X. So these values are here. 2, 3, 4. Now how to find probability? I told you when it's random without replacement, then you can use combinations. So for 2 paper bag and 2 hard bag, use this 6C2, 2C2 divided by total 8C4 and write your answer in fractional form. 314. Now for this, use 6C4, 8C4, and for this 1 minus this and this will give you this, because total probability is always 1. Now given that mean is 3, find variance. So first get Ex square. For Ex square, write sigma x square Px. So how would you do this? X square means square of this, 2 square times its probability. Then 3 square times its probability. Then 4 square times its probability. This is Ex square. This is the formula of variance, and that's the variance. Please check the solution. Now how to choose the values of X? Understand with the help of this question as well. A company produces small boxes of sweets that contain 5 jellies and 3 chocolates. Jamil chooses 3 sweets at random from a box. Okay, so the requirement is 3. So 3 is the requirement, total 8, jellies 5 and chocolates 3. Draw up a table. Jamil chooses number of jellies. I mean, this is the requirement. X represents J. Now, which values X can take? Let me explain this to you. X, J, C, 5, 3, 5, 3. So J can take all 3 with no C and 0 with 3 chocolates. This is, here 0 is possible because total is 5, and this 3 is possible because this is 3. What if this is 2 chocolates? Then this 3 would not be possible. Then the answer would be 1 and 2. But since this is possible because of this, so J can take 0. I mean, there could be 0 jellies minimum. So the values of X are 0 to 3. 0, 1, 2, 3. This is the minimum, this is the maximum. This is here. And again use combinations. For 0, no jellies, all chocolates. 3C3, 8C3 and so on. Now possibility space. A fair 3-sided spinner has sides 1, 2, 3. A fair 5-sided spinner has sides numbered. This. Both spinners are spun once. For each spinner, the number on the sides on which it lands is noted. See, I have made the possibility space diagram. All these numbers are here and these numbers are here. You can switch their places as well. The random variable X is what? Is the larger of the two numbers if they are different. See, if numbers are different, like here 3, 2, then X represents 3. And their common value if they are the same. If numbers are same, then X is 2. What if numbers are same? X is 1. Numbers are same, X is 3. Numbers are different, X is 3. Now find the probability x3 or show that x3. Now check 3. See, the score is 3 here. From here 3, x is 3. Larger number, same number 3, 3, 3, 3, 3, 3. Now count these numbers. 1, 2, 3, 4, 5, 6, 7. 7 upon 15. See, possibility space diagram made this question very simple. Now x means, now drop the probability distribution for x. X is the larger of the two numbers if the numbers are different, and their common value if they are same. So the minimum value of x is 1. See, both numbers are same. So the minimum value of x is 1 and maximum 3. So 1, 2, 3. The probability of 3 is here. Probability of 1, only two numbers here, and 1 minus this, and this will give you this. So possibility space diagram make the question very simple. See the solution, please. Since I have to cover representation and permutation, so this is the last question of probability distribution. Mean. How to find mean? For mean, take the product of these two. Sum of the product of these numbers. 1 into 2 upon 15, 2 into 6 upon 15, 3 into 7 upon 15. Sum of these will give you mean. Alright, that's the mean. For ex square, just square this number, square x, and the rest is same. This is ex square, this is the formula of variance, and standard deviation is this. This is an exact answer, so leave it as it is. This is another possibility space. Okay, let me discuss this as the last question of this chapter. Now x is the sum of the two numbers. Just take the sum. So these are the possible values of x, -1, 0 and blah blah. And probabilities are very simple. -1 is once out of 4 3s are 12. And you can easily get mean and variance. This question is extremely important. Fortunately, I've got this question. Here we have two options. See, in this question, there is just one operation, sum. In this question, there is one operation. Basically, there are two, like same numbers and larger numbers. So I listed all the outcomes. See, I listed all the outcomes here because of two operations or two informations. Here just one information, sum. I basically sum all the numbers, like -2 plus 1, -1, -2, 0. But here we have two mathematical operations. See, if the two values of x are the same, the random variable y takes that value. Meaning, like 1, 1, the y can take 1. Otherwise, y is the larger value of x minus the smaller value of x. 3 minus 1, 2. This is the value of y. That is why I listed all the outcomes. Now, which values y can take? 1, 1, so 1. 2 minus 1, 1. 3 minus 1, 2. Right? 4 and so on. Now, how to write the probability of 1? See, y is 1. Here 2 minus 1 is 1. Y takes the value. Y is the larger value of x minus the smaller value of x. So 2 minus 1 is 1. So y can take 1. So 1, 1, 1, 2, 1, 3. Sorry, 1, 3 not is possible. This is 1, 1. This will give you 1. 1, 1. All underlying numbers. These numbers will give you probability of 1. This 1. 2 minus 1, 1. Y can take 1. This is this one and this one. Now let's count these dots. 1, 2, 3, 4, 5, 6, 7. And same, y is the larger value of x minus the smaller value of x. There is one number is left. I think which one is that? 1, 1, 1, 2, 2, 1, 2, 3, 3, 2, 4, 3. So 8 upon 16. 1 is missing. 1, 2, 3, 4, 5, 6, 7. If the two values of x are the same, the random variable y takes that value. Okay, this is done. Otherwise, y is the larger value of x minus the smaller value. So 2 minus 1 is 1. 3 minus 1, no. This is 1. 1. This is also 1. 1. 4, 3, 1. One number is missing. This is 8 upon 16. Let me check the solution of this. Probability distribution. Question number 6. Question 6 of probability distribution. Probability distribution, question 6. Yeah, it's 7 upon 16 because it was coming 7 upon 16. 7, 5, 3, 1. Okay, let me copy this. So let me correct this. So 7 upon, it was by mistake. Okay. So 7 upon 16, because 7 dots, 5, 3, 1. Okay. Now you can easily get, okay, conditional probability. Find the probability that y is 2 given that y is even. So this is so simple. Y is even means 4 and 2. So just add these two numbers probability. So let me correct this as well. So 6 upon 16 and y2 and y is even. 2 and even. So 5 upon 16. So the answer is 5 upon 6. Yes, this is the right answer. Okay, probability distribution is over. Now 2 chapters are left, representation of data and permutations and combinations. Alright, let me first do a measure of averages and spread. Before starting this, let me tell you the formulas. Here. So ungrouped data without frequency raw data. Ungrouped data means raw data or without frequency data. For that, mean is x sigma x over n. This is variance. All these formulas are given in MF19. And this is assumed mean. You have to learn these formulas. Sigma x minus a over n, this a is here. Sigma x minus a whole square upon n, and only this thing is here, not a. Group data, this formula and this formula both are given. Sigma fx square over sigma f. Now, combined mean, you have to learn this. Sigma x1 plus sigma x2 divided by total. Or if you replace the value of sigma x is n x bar. So n1 x1 bar, n2 x2 bar. We use these formulas according to given situation. Now this is the variance, standard deviation. Sigma x1 square, sigma x2 square, n1 plus n2 minus combined mean square. Now data. If data is even, then if data is even or odd, the formula of median is unchanged. It's n plus 1 upon 2th observation. But for quartiles, we have different formulas. For odd observations, 1 upon 4 n plus 1th observation. 3, 4 n plus 1 for Q3. For even number of observations, see the whole bracket. 1 upon 4n plus 0.5th observation. 3, 4n plus 0.5th observation. You have to learn these formulas as well. Outliers, lower boundary is Q1 minus 1.5 IQR. Upper boundary Q3 plus 1.5 IQR. Sit. Now, measure of central tendency. Here. 1 minute, please. Allahu Akbar. Alright, so we have sigma x minus 50 square, and we need sigma x square. So this is the formula of variance I just told you, and just substitute the values. So this result is 671.0, n is 22, and this is here, so this is sigma square, right? Exact answer. Now use this formula of variance for sigma x square. This is available in MF19. We have mean, we don't have mean, in fact, we have to find mean. Mean is sigma x minus 50 over n plus 50. So mean is 53.7, right here 53.7, and get sigma x square. Please check this solution. This question is very important. First get sigma square, then get x bar with the help of this mean formula, and then substitute mean here and get sigma x square. Here we need value of n. So use the formula of mean. Mean. So I equated this formula with this formula of mean. So sigma x over n, and this is here. So this result is 144. This result is 944. We need n. Shift this on left side, take the LCM and get n. Combined mean. We have sigma x, the heights of 6 members. This is the first group, 6 members of the volleyball. Sigma x square, we have both, and 11 members of the hockey team. The data is here. Find the mean height. This is very simple. We have sigma x 1050, we have sigma y, and total is 17. This is combined mean. Now combine standard deviation. We have the complete data, nothing is missing. So this result is here, this result is here, this is here, total is here, combined mean is here. Here we need mean is 40, find the value of k. This we need this k. N is 40, mean is 34. So just copy the formula. 34, 40, 520, get k. Find the variance. So this information is here, this is here, and this is the variance. Please check the solution. Here we need n. This is very simple, a repeated question in fact. Alright, now the next is representation of data. You must know how to find quartiles, median from a stem plot. This is the formula for median, and this is the formula for quartile for odd number of observations. There are 39 males and we need 39 females as well. We need median quartiles. So 39 plus 1 divided by 2, 20th observation. So 9 plus 4, 13, 13 plus 8, 21. So this is the 20th. 2 to 7, check the unit, 00. This means thousands. 20 to 20, 300. 20,300, 20,200. So 22, 7, 00. Q1, write 39 here. So 39 plus 1 is 40 divided by 4, 10th observation. This is the 10th observation. 21, 700. Similarly, get Q3. Now, box plot. For box plot, it's compulsory to label the axis. Salaries in 100. Salaries in 100. So, how to draw box plot? Either you could draw female first or male first, but it's better to draw this on first and then this second, and label them as well. So the smallest observation is 200 and 100 is common. So 200, and similarly, this is the smallest observation, this is Q1, median, Q3, highest observation. And make sure these whiskers do not enter the box like this. So this is the box for females and this is box for males. Now observe their medians. Median of male is higher than median of females. So on average, male salaries. So male have high salaries than females. Right? Now this is cumulative frequency graph. So draw the cumulative frequency curve instead of polygon. It's better to draw the curve because in exam they ask curve rather than, they prefer curve. This is polygon, this is also fine, but try to draw a curve. Let me show this in Feb March paper. I just did this. Feb March paper. See, frequency graph means draw frequency curve, cumulative frequency curve, smooth curve. Okay? And for curve you need boundaries. Length can't be negative, so don't subtract 0.5 from this, just copy this 0. This is 9.5, 9.5, 14.5 and so on. Cumulative frequency here. You all know how to draw cumulative frequency, you have done this in O-level math. So copy this 15, 15 plus 48 this, 63 plus this, and then finally we have same number. For this value always take 0, for this number, and these are the corresponding numbers. %40 of these fish have a length d centimeter or more. Use your graph to estimate the value of d. 40 centimeter or more. This means take the upper part of the graph. This part. So 40% is 60. So 150 minus 60. Whenever it says more, then get the percentage first. Now subtract this from total. Check the 90th observation. 150 minus 60, 90, 90th observation. 16.5. This part is very important. Whenever it says more or at least or minimum, always do like this. Mean is very simple. For mean you must have average of these numbers. This is the histogram question. You all know how to draw histogram. You have done this in O-levels. Class boundaries are here. Frequency densities are here. Frequency divided by class width will give you frequency density. And make sure you take class width from here, not from here. 10.5 minus 0.5 will give you 10. What is the greatest possible value of IQR? So for that you have to draw cumulative frequencies. For IQR or median, always get cumulative frequencies. Now take the 50% of this, 25% of this, which is 25 lies here. So this is the interval of Q1. Q1 lies in this interval. 75 lies here. This is the interval of Q3. 31 to 50, 11 to 15. Now what is the greatest possible value of IQR? 50 minus 11, 39. Least possible value, 31 minus 50. For greatest, take the difference of these two. For least, take the difference of these two. Now mean is here, sigma fx over sigma f. And variance is also here. In variance, we square these 5.5 square, x square. Please check this solution. Comparison. Remember, in box plot, always use two things, median and range, to compare the boxes. Since median of A is greater than median of B, so you have to say on average, must mention on average. This means you are comparing their median. On average, machine A produce longer rods than machine B. Okay? Because A has greater median. And variation, the range of B is greater than the range of A. So more variation in machine B's rods than in machine A's rod. This is the way to compare. Give to comparison or make to comparison, and this is the way to make to comparison. One with respect to median, one with respect to range. In a stem plot, must mention the key. This is in thousands of dollars, so 41 means 41,000. I told you, don't draw polygon, draw curve. Curve is better. I will edit these things later. Now this is one of the most important questions. Calculate estimates of the mean and standard deviation. Understand this very carefully. This is continuous. So in case of continuous data, the first value of this class must be 0. Remember, if data is continuous, the first value must be 0. This is cumulative frequency table, and for mean we need frequency distribution. This is frequency distribution. Distribution, not density, okay? So class boundary. In case of continuous data, takes first value 0. Now the rest is simple. 20 is exclusive because here 20 is inclusive, so it should be exclusive. 30, 40 and so on. Now for mean, take the average of these numbers. And how to find these frequencies? Very simple. 150 minus this will give you 16. This minus this will give you 28. This minus this will give you 58 and so on. These are the mid values, the averages of these intervals, class boundaries. Now for mean, take the product, sum of product of these numbers. And this is very simple. For variance, just square the x values, and minus the square of mean. Alright, I think this is enough from representation. Now finally we have permutation and combination. Alright, 1 minute break, then I will continue this, okay? 1 minute please. One of my lecture is uploading. Let me check that lecture. Okay, it's uploading. Okay, permutations and combinations. A group of 8 friends travels to airport in 2 taxis P and Q. Each taxi can take 4 passengers. The 8 friends divide themselves into 2 groups of 4, one group for taxi P and one group for taxi Q, with John and Sarah traveling in the same taxi. Find the number of different ways in which this can be done. So John and Sarah will travel in the same taxi. So let's suppose John and Sarah will travel in taxi P. So this is JS in taxi P. Now remaining people are 6 who can travel in taxi P. This is taxi P. So 6C2. And for taxi Q, just write 4C4. And this can be, interchange. John and Sarah can travel in taxi Q as well. So just multiply this result by 2 or with 2. That's it. Second point. Each taxi can take 1 passenger in the front here and 3 passengers in the back. Mark sits in the front here of taxi P and John and Sarah sit in the back of taxi P next to each other. So this is John and Sarah. Let me explain this here. John, Sarah, they can switch their places in 2 factorial ways and they can switch as well. This group can switch in 2 ways, 1, 2. So 2 factorial into 2. And 1 person from remaining 5 can come here, 5P1. Okay? And this is Mark. See, John, Sarah can switch their places in 2 factorial ways and this group can switch their place in 2 ways. So for Mark, either write 1 or ignore it. John, Sarah 2 factorial and 2. Remaining person 5P1 and taxi Q random 4 factorial. 480. The 40 members of a club include R and S. All 40 members will travel to a concert. 35 members will travel in a coach and 5 will travel in car. R will be in the coach and S will be in the car. So very simple. R is in coach. So we need remaining 34 out of 38. And S is in car. So 1 and remaining 4 from 4. Okay. $38. So left over 4, 4C4. 1, 1. So this will make 35 in coach. And this will make 5 in car. Okay, find the number of different arrangements that can be made from the 9 letters of the word jewelry in which the 3 E's are together and the 2 L's are together. Okay. 3 E's together and 2 L's together. All 3 E's, all 2 L's. So write 1 for this, 1 for this, and remaining objects are 4. So 1 object, 4 objects. So altogether 6 objects, 6 factorial. Find the number of different arrangements that can be made from the 9 letters of the word jewelry in which the 2 L's are not together. Very simple, use spaces method. Altogether 9. So first arrange, remaining letters are 7. So 1, 2, 3, 4, 5, 6, 7. 7 factorial divided by 3 factorial for 3 e's. And slots are 8. You can fill any 2 slots out of 8. So 8p2, and both filled slots are identical, 2 factorial. So first arrange remaining 7 factorial by 3 factorial. Then arrange 2 L's. Put 2 L's in any 2 slots out of 8. And both slots are the same, so 2 factorial. Now this question is important. Combinations with repetitions. 4 letters are selected from the 10 letters of the word summertime. Find the number of different selections if the 4 letters include at least one M and exactly one E. So make all possible selections, right? 1 E, 1 M. Altogether we have 10 letters. 3 M's, 2 E's and 5 remaining. So take any 2 from remaining 5. 5C2. Now 1 E, 2 M's, and we need 1 from remaining 5. Since there are 3 M's, so this option is also possible. Now add all these. Okay, find the number of different arrangements of the 9 letters in the word in which first letter is C, fifth letter is T and last letter is E. So these, positions of these letters are fixed. They can't change their positions, okay? So remaining letters are 6. So 6 factorial divided by 2 factorial for 2 L's. I'm taking important questions only. Okay, Mr. and Mrs. Ahmed with their 2 children, Mr. and Mrs. Baker with their 3 children are visiting an activity center. They will divide into 2 groups. 9 people divided in 6 and 3. So 9C6, 3C3. You can do in any order, like 9C3, 6C6. Both mean the same thing. 9C6, 3C3. 5 of the 9 people are selected at random for a particular activity. Find the probability this group 5 contains all 3 of Baker children. So all 3 Baker children, and from remaining 6 we can get 2, because altogether we need 5. 3 plus 2, 5. And probability 9C5. This question I think is important. This is spaces method. I'm leaving this one. Find the number of different arrangements in which there is exactly 1% between Mr. Ahmed and Mrs. Baker. So Mr. Ahmed and Mr. Baker, 1%, anyone from 7. So just write 7 or 7p1. And these 2 can change their place in 2 factorial. A can come here, B can come here. So 2 factorial, and this is 1 block, 1 object, 6 objects, 7 objects, 7 factorial. Find the number of ways in which committee can be chosen if the sister and brother cannot both. That means total minus both. Always use this method for simple cases, right? Now this question, this is an important question. A similar question of this type came in, I think, March 26. I think so, I'm not sure. Find the probability that the arrangement has both R's together, given that all 3 E's are together. This is conditional probability. Both R's together A similar of this question, not conditional probability, but with respect to this situation, came in 2026 March. Okay, so R's and E's together. So R's together, E's together. This should be in numerator, 120. Only E's together. This should be in denominator. So this is 1, this is 1. These are 3 objects, so altogether 5 objects, 5 factorial. Only E's together. So remaining 5 with 2 R's. So 1 object, 5 objects, 6 objects, 6 factorial, 2 R's, 2 factorial. I'm finding a question which contains selections with probability. Selections with probability question. Yes, this question is very important. One of the most important questions. Selections with probability. Here, please remember in this, for questions of these types, we do consider selections of identical objects. See, I need 1 O from 3, I have to write 3C1. Anyway, 4 letters are selected at random from 8 letters of the word tomorrow. Find the probability. The selection contains at least 1 O and at least 1 R. Okay, make all possible selections. 1 O, 1 R, remaining 2 out of 3. See, these are remaining letters and these are O's and R's. So, to select 1 O from 3, write 3C1. This question contains probability. This is basically probability with selections. So, probability with selections, always consider C. And just selections, not probability, don't write this. We did a question of just selections for repeated letters. Anyway, 3C1, 2C1, 3C2, 18 outcomes. 2 O's out of 3, 3C2, 2C1, 3C1. I'll show you one other question in which I will not write this thing. That question is just for selections. So, do like this, get the total and write the answer. Right? Now, let me find a question which is just pure selections. Yes, this question. In this question, I will not write C for identical objects. See, there are 3 E's, 1 R. I have altogether 3 E's. See, 3 E's. I'm not writing 3C2 here for this. So for just unique selections, right, only for selections, not probability, don't use C for identical objects. Never. We have 2 R's. I'm not writing 2C1 here because this question is only for selections, not probability. And this question was selections with probability. So if you have a question probability with selections, then even for identical objects you have to consider the selections of identical objects. Here we consider, we wrote 3C1, 1 O out of 3, 3C1. I hope this lecture would help you to refresh your S1 work. If you find this video helpful, please share it with your friends so they can benefit as well. All the very best for your S1 exam, and please subscribe the channel as well. Share the link of the channel with your friends. Sallallahu alaihi wasallam. Alhamdulillahi Rabbil Alameen. Allah Hafiz.